So right now we don't have a good model of how to do segmentation with deep networks, and at the same time recognize object. So how could we do things? So we know that we have to group features together, maybe things that move in a similar way and so forth. So maybe tracking can offer some insight, and that's one of the idea when I can show you that doing a system in isolation where you have tracking, segmentation, and recognition isolated, it's not going to work to give you a good tracking system. So tracking could offer some insight, because think about tracking. Tracking means that I have to recognize the same thing in different images. You kind of need to know a little bit of objectness about tracking. So when a face, for example, turns, or an object turns from one view to another, you really need to know a little bit more about the object in order to be able to detect it. And if you can detect it, you can segment it from the background. Tracking is not going to work if you're not able to segment the object from the background, because if you start picking up features of the background, your tracker will fastly drift. Unfortunately, if you look at neuroscience model of tracking and what we know about vision system and our own vision system and how it performs tracking, there's really not a lot of information. All they say, for example, in this paper from 2000 is that you need to track an object in the feature space. So, well, that's not a lot of information, because we already kind of thought about this. What makes an object is that it has some features here that look similar in color, in texture, things that move together. You need to group things that are similar together in the feature space. But it offers some insights. It basically tells you that you don't want to track things in the input pixel space, but you want to track them as inside the layer of a deep network, for example, as a second layer of a deep network or a third layer of a deep network, where you reduce the information, but you combine it in a way that you have information about the object itself. Unfortunately, you can't really go too deep, because the neuroscience papers also say that we are able to segment an object or figure out what an object, proto-object is, just by activating maybe V1, V2, maybe part of V3, but not really going all the way to inferotemporal cortex. So it has to be fairly, let's say it could be the output of the first or second or third layer of a deep network. Here in our lab, we looked at techniques to be able to track, and we developed a technique that is called SMR tracking. And this really works at the pixel space. And it works fairly well when it tries to find, segment an object from the background, from purely the input pixel space. Because what you basically do is, instead of, usually you take a region, a box, because you don't have clear segmentation of the object, and you try to track pixels that are in both the previous image and the next image. You try to track them and see if two pixels are fairly close in the two images, then they might still belong to the object. Otherwise, they might belong to the background, and this is because the object that we want to track maybe maintains more of a the pixel in the object maintain more of a grouping together than the background. So, for example, if you have a person moving, then it could be that a portion like the torso is remains quite the same, but other portion of the image are quite different. For example, here it contains a leg, but before it didn't contain a leg. So you can reject parts of the template that you're trying to track, and you can try to do a better job at tracking. Unfortunately, even this system that we develop in the lab, it's kind of an isolated system, and only track features, but has no notion of objectness. So if the object disappears, or you slowly, if it's slowly occluded, then the system will start tracking something else as part of the background. So even this system is not working all the time, because he has no notion of object. It doesn't know really what's an object. It's only looking at the pixel at the input space, which is not really enough. You don't have enough features. You're not extracting any deep layer features there to recognize the object and how it could be grouped together. For this, I think this system is not completely usable as it is right now. And what I think is the solution really is that we have to find ways where that it could employ deep network to group outputs together, both for segmentation but also for tracking. In particular, I think the solution is to really employ convolutional neural networks. So, of course, to think about it, if a convolutional neural network was trained very well to recognize a face in every frame at different position, he would be able to find the face at every location, and if the location were fairly close to each other, the convolutional neural network would be a very good tracker. And in reality, there has been a few examples of this, but not a huge amount at the moment. So we don't have good models basically that can offer insights about tracking with convolutional neural network. Convolutional neural network should be able to track an object in multiple frames, and maybe one of the best examples that we have is a couple of networks from Pierre Sermanet, for example, in tracking humans, that they were working fascinatingly well in recent times in the group of Yann LeCun. So in theory, a deep network should be able to track an object and detect it at every frame, and I think that's really the solution, what one needs to go for, instead of using a separate tracker. Also, deep network can also be used, and convolutional neural network can also be used to do segmentation. We have a few papers in this area that are quite nice work, and they're done by Srini Turaga, which has done some nice work in the area of segmenting with learning how to segment images. So I point you to this. I'd like to see, personally, I think this is a hot area, using deep network as trackers and using deep network for segmentations. And I'd like to see more work in this area, especially in tracking, deep networks as trackers, deep network for segmentations.